Well, good morning, good afternoon, or good evening, depending upon when you're watching this webinar. My name is Dave Nagel, and I'm very excited to connect with some new friends and colleagues in Yelm Community Schools, as well as with some that I've already had the pleasure of meeting. This is a four-part webinar series. This is part one that will introduce some aspects of visible learning and introduce some of the new members who are going to join the cohort, specifically the classroom teachers that are going to join their administrators and leaders when we come together here later this month in November. So this first one will focus on the overview of visible learning research. Each one will be about 10 to 15 minutes. This one will be probably the longest one. And what I'm just going to encourage everybody to do, you've got a working handout that goes with it that I'm going to guide you through. And there's going to be times during the webinar to stop and pause and record some ideas and things. But I've kind of set it up so you could watch these over the course of the next few weeks, do some learning, ask any questions when I put my email up at the very end of the session, and then give us a better chance when we come together later this month to make the days as productive as possible. So a little bit about myself. Been in education now coming up on 20 years. I was specifically a middle and high school administrator and teacher, but I've been working in this role for almost 14 years now. Need to change that slide. And I've twice been certified in John Hattie's visible learning research. So I'm very fortunate to share some of my expertise with the team and help guide their learning as we move forward. As I mentioned, you have a handout that looks like this. It's broken into 4 parts, so we're going to be focusing just on part 1, the overview of the research. And we're going to go ahead and get started, but please make sure you have the handout with you because it's really important to be able to record some of the things I'm going to ask you to think about throughout these 4 sessions. Our success criteria by the end of this webinar is that you can articulate some of the key findings from the visible learning research and list some ways to apply those aspects into your school or your classroom. One of John Hattie's core messages is always to know thy impact, to make sure that we as teachers or administrators predominantly focus on knowing what is the impact I am having on the students that I'm working with. And are my actions really driving the highest levels, above all else, of student learning? We're focusing on learning, which is a little bit different than achievement. What we mean by that is students could be passing Smarter Balance at a level that's above and beyond the expectation, but their learning could actually be going backwards. They could be digressing in their progress. Or a student could be really accelerating in their progress and growth, but they haven't necessarily met the bar. Hattie focuses on that first part, that progress and growth is what's taking place, because when that's happening, learning over time is going to be very apparent. You see, you have a handout that kind of looks like this. I'm going to walk you through some of the aspects of the research, and there's a chance for you to jot down some ideas around some of the specific ones that I'm going to go into with more depth. What I've done here is I've listed what are called influences on student learning. The difference between Hattie versus maybe a Marzano is Hattie's not talking about strategies necessarily. Within his influences, some of them have specific strategies. But these are things that influence student learning. So please take a moment. I'm just going to go for about 10 or 15 seconds. Pause the recording if you need to. But out of this list of 15, please jot down what you think would have the highest impact on student learning and the least impact on student learning. Come back in about 15 seconds, and I'll give you a chance to pause the recording if you need more time. Welcome back. Again, if you needed just a few more moments, please pause the recording because I'm going to go ahead and move on. But hopefully you've had a chance to list the top 2 and bottom 2. So what John Hattie did is he conducted what are called meta-analyses, which are studies upon studies. And then he synthesized them. So a lot of times people need to realize it's not Hattie's research. It's other people's research that he synthesized. And it includes now over 500 million students. So we can see the scope and magnitude. And what he used was an effect size scale, which allowed him to synthesize the research regardless of where the studies took place. So there would be a common scale. So if students are taking an SBAC in Washington State, we could take the same dissertation and study from somebody in Germany where they take what's called the arbiter. It's a common scale. What Hattie found was that the typical effect of everything we do in schools is 0.4. So a way to think about that is 0.4 is approximately 1 year's growth in about a year's time. And anything less than 0.4 has to be considered less than average. I'm going to dig into that a little bit as we move forward. You see at the top of your handout something called the barometer of influences. These are a way that Hattie kind of put all of his research on a common scale. So there are some things we'll talk about that actually make learning go backwards. They have reverse effects. Some things are just developmental. We would expect learning to take place if the individual is just breathing for 365 days. What Hattie calls typical teacher effects is not a critique. In fact, it's a compliment. Almost everything we do in schools works, and a lot of things aren't designed to work. It's a compliment to teachers. But he would say we need to search for the zone of desired effects, the things that have the greatest impact on learning and well above the 0.4. Another way to think about this is imagine if I said there's going to be 10 3.0 earthquakes in the Yelm area in the next week, or one 9.5. What might get your attention a little bit more? Obviously, it's the 9.5. It will have a greater impact. So 10 threes doesn't equal 30. So when we do a lot of little things in our classrooms, doesn't necessarily mean we're going to get the same effect or even close as the things that really have a great impact on learning. So now I put the list back up. But I've also listed not only ranking them, but also the effect size next to them. It's a good chance for you to pause the recording. I will move on before you might have a chance to digest it. But anything less than 0.4 is less than average. And again, this is just 15 of his 250 influences on student learning. We're going to dig into some of these in more detail, but it's a chance for you to think about what did you say were the top two and the bottom two? Were your thoughts validated? What questions do you have? One of the things Hattie did as well is when he synthesized his research, he put them into what he would call houses. And he grouped them by things like the curriculum, things the student brings to the table, the home life, but also the teacher and the approaches to teaching. So he ranked them, but he also put them into different groups. I'm going to walk you through now 6 or 7 of these studies, and you have a chance to record some ideas on your handout. But one of the things is you'll always see the ranking. And I don't know if John is at 252 or 253 because he's always updating it. But last is mobility. Students start the school in Yelm. They go to Longview, Washington for a while. Maybe they come back to Yelm and go to another district and come back. And I know we have some of those students. Nothing we can do about that, but I want to dig into this one specifically. But it's always last. It's the worst thing that can happen to a student. And the average of the 181 studies, and what I'm highlighting here, is that there was 181 dissertations. That means 181 large-scale studies to get to that negative 0.34, which is 2 years negative growth. 540 effects means that there was 540 indicators within the studies around student achievement or learning. Math achievement boys and girls. Math achievement boys and girls if they had an IEP, for example. So you can see how the scope can grow. But we have to dig in. We don't know enough yet from that number. When we dig into the research, it's interesting. In over 12 of the studies, one of the things they found is that when students have met and found a peer friend within 48 hours, it mitigated the negative impact, brought it down to almost zero. The student was new in my middle school. I would say get him universally assessed, get him into a classroom, get him into some RTI because he's behind. No. He needs to shadow another student for a couple days, go where they go. Because maybe on that second or third day when they've met some friends and there's someone who can help them with their locker and just feel safe at my school, they got a better chance to learn. So I'm highlighting here, even in the worst case, we can dig into what tells us within the research of things we can do when we are faced with challenges. So we can't just look at that number and think we know the whole story. But I also like to highlight this one, retention. There's never been a study that links retention to learning. But I got to tell you a story about a family that I personally knew. They had 3 children, 12 and 11, and then the proverbial accident showed up. So he was much younger than his siblings. When he got to 3rd grade, he started to struggle a little bit. Academically, he passed, but behavior was a little bit south. And his parents influenced the school, said, we want to do this again. That didn't work. But we're going to give him a new teacher. That one didn't work. We need him to be in the upper level math group as well because he's a boy. So he's BORED, which means he's BAD. Even though his wife might disagree, not only did he have a pretty good year, I actually think I turned out okay. I'm talking about myself. I can't look at the mountain of evidence on retention and say, well, I don't agree with that. I have an anecdote. And so there's a chance that some of the research might challenge us, but we have to dig in and go, but what is it about that we have a different perspective? Or maybe there were other things involved that we don't quite understand that are much more than, for example, the retention. Homework. A lot of people have an opinion about homework, and as we see here, the average effect is 0.29, so it is below the average. But homework, like a lot of studies, had moderating effects. Kindergarten, first, second grade, very little impact on learning. Guess who does my kindergarten and second graders' homework very often? Me. Now, let's hear the whole story. It's not that they can't do it or that it's detrimental, but often they might not have the stamina or concentration levels to really focus on learning at that time. At the same time, their second grade teacher, my second grader, his teacher might erroneously think that he understands the concept because he comes back to school and all of the problems are correct. It's because his mom checked him and made him do them over. We've got to be very careful of trying to articulate learning at that level. It's not a bad idea that they bring the work home and work on it, but I can't equate it to learning. Now, at the secondary level, it's much different. 0.59. I knew it. We should assign more homework. It's not about assigning. Here's some of the synthesis around homework that I would imagine most of us would say that's a blinding flash of the obvious. The more the student can do the work, it validates their confidence. The more they can't, it might validate that they're not smart enough. Here's where the rubber meets the road. Task-oriented, specific on a problem or specific to a skill that they're developing, rote practice. Deep learning or project-based homework, ineffective. Now, what we're not saying here is students can't take their project home and work on it. But what we are saying is that if students have to teach themselves, it's not necessarily for practice. A way to think about this is as a science teacher, because one of the areas where it hasn't had the highest effect is in science. What students might need is, for example, to go home with 12 variables and figure out which one's the dependent or independent one to then bring back the next day to work on their lab. Now it's focusing on a skill that they can apply at a different level. So we're not saying that they shouldn't do homework. What we are saying is that maybe it's focusing on certain things differently, and it's focusing on practicing and learning. I always like to combine these two. So you'll notice on your handout it says direct instruction and problem-based learning. Direct instruction has an effect size of 0.59. Problem or project-based learning, like we would expect the term to be, 0.15. That's surprising? Certainly. That's because we have to dig in again. Direct instruction is not what I'm doing right now. It's not didactic talking. It actually has 7 distinct steps. And if we look at some of those, let's take a look at the first 2, completely related to teacher clarity. Step 5, guided practice. I've got to make sure you grasp those important concepts before you move on to the deeper level learning. The reason why problem-based learning hasn't had the effect it should is if I give you a problem, like for example, if somebody gives me a problem to build a bridge across the Golden Gate Bay to withstand seismic waves up to 10, that sounds really exciting. I have no idea how to get started. If I don't have the surface knowledge, it can actually have negative effects. At the same time, if I'm ready to move on to the problem and I'm held hostage because I didn't jump through every hoop, then I'm going to lose my interest. Problem and project-based learning can and does have a high effect when it's used well. So this is where we have to be very careful of just looking at the numbers and thinking that we know the whole story. A couple more. Teacher-student relationships, 0.72. Couple of points here. If you look at the number of studies and the effects, a lot of evidence around this. Now, 0.72, again, is the average. That's because there's times when it didn't include some of the things it needed to. What Hattie would say is the word teacher needs to come first. Now, we as the adults have to initiate the relationship. Some students are more likable than others. I know this for a fact. When my first son was born when I was 35, there was only 5 names left. That was my attempt at a joke. But all joking aside, we know that it's a lot easier to build relationships with some students. But again, we got to dig in. Because teacher-student relationships actually has moderating effects. Sorry, my slides were off there for 1 second. The moderating effects around teacher-student relationships have to do with things like empathy, making sure that we don't sympathize with students and we don't lower the standard, but at the same time, we also raise the bar and make sure all of the students have the same ability to grow and develop. Here we go. I have my slide back. I apologize for that, guys. Empathy isn't sympathy. Empathy is understanding that the student is mobile and I got to make sure they feel safe before I have them learn, but I'm not going to lower the standard. Empathy is the student is in my classroom and they're hungry and I don't allow food. Oh my God, the kid's hungry. I let him sit in the back and eat his donut before we start class. But then I keep him out of recess because I'm not going to lower the standard. Non-directivity, as we'll get into even more, is when we make sure that we don't make the students learn our way, that we allow them multiple paths to learn. So teacher-student relationships is more than just the warmth and the kindness. Certainly that's there, but you can see it has a lot to do with how we are looking at our students and helping them grow and develop. Another one I like to include, because this is one as a teacher we might be able to take back and apply right away: space versus mass practice. What we're saying here is that we need around the same number of practices to develop mastery, about 12 to 24. But the type of knowledge and the number of iterations is different. Learning that is procedural learning, mass practice up front, and then spaced out over time. I can't learn concepts in the same way. I can learn how to set up my math problem, my timeline. That's procedural learning. We teach kids procedures at the start of the school year. We have to revisit them. We can't teach main idea. We can't teach the concept of lift. We can't teach the concept of love in mass. We have to teach it over time. That might get us to think about when we're designing our units. The procedural knowledge that we have to hit a lot early versus the conceptual that we have to give ourselves a chance to let it soak in and develop over time. Finally, and we hear a lot about this, the new number one, collective teacher efficacy. Individual efficacy starts with ourselves, our ability to promote change in our students, but then collectively, we think about it, we put our best efforts and the challenges in front of us that we attack forward. We have a chance, as we see Hattie's research, 1.57. It's almost 4 years growth in 1 year's time. We have to be careful. Collective teacher efficacy isn't something that just happens. There's some conditions that will promote it. One is that we apply new knowledge. We have to, as teachers, be able to develop mastery. Have to have positive interdependence. We have to depend on one another and be accountable to each other and have fine-grained discourse around learning. Now, when we're at our PLC meetings, we're not just looking at student scores, we're looking at student work and really digging into why they're getting results correct or not correct. Last but not least, when we look at all of Hattie's synthesis, it's obvious who is most in charge of their learning. It's the student. But number one is the teachers. The teachers have the most influence over student learning. We are the ones, when I say we, I mean the teachers that are listening on this call, listening to this webinar, to have to pull the good stuff out of the students and try and minimize some of those other challenges. But I think it's even more of a compliment to what we already knew. It's not that the home or the school or the peers or the principal don't matter, but it's the classroom teacher that has the greatest impact on student learning. Really appreciate your time. This is one that was a little bit long-winded because it's just a good chance to give an overview of the research, and then hopefully I provided some examples of where we have to be careful and not just think we know everything with the numbers. But hopefully you can articulate some key findings from the research and find ways to apply John Hattie's visible learning to your specific classroom. If you have any thoughts or questions, anything that I went through fast or I didn't go through with enough detail, or just you had another question, as always, please feel free to shoot me an email at dave.nagel@corwinlearning.net. You see my Twitter handle there, and you can visit the corwin.com website or my own personal website, davenagel.com, for some more information. Thanks so much. Look forward to talking with you on webinar 2 and seeing some of you again here on the 28th of November and meeting some new faces. As always, have a great rest of your day.